All right, this is the last lesson for this unit. It's a small unit, but with lots of important stuff in it. So our goal is I will be able to describe or draw time distance graphs. So hopefully we have some time for you to actually play with the CBRs, and that was something where actually it says down here that it's a way to collect data using the graphing calculator. So hopefully I'll be able to take a couple groups out at a time and actually show you how this works. So first of all, describing the motion of an object is occasionally hard to do with words. Sometimes graphs help make motion easier to picture and therefore understand. So we're making time distance graphs. So here it says time is always plotted on the x-axis, in other words the bottom. The further to the right of the axis, the longer the time from the start. And so that is actually quite important for you to recognize. So the further to the right on the axis, the longer the time from the start. And the distance is plotted on the y-axis, and the higher up on the graph, the further from the start. So that means the start is starting at 0, 0. So they're saying that time goes along the horizontal axis, distance along the top. Okay, so that means as the graph is going on, the further I am from 0, 0, as far as time goes, the longer time has happened. The higher I go on a graph, the further I am away from my starting point. So there's different types of movements, and we're going to look at those. So if an object is not moving, so in other words, it's not moving, it's a horizontal line on a time distance graph. And the reason is because time's going on. Okay, it's going on whether you're moving or not. So time keeps on going, but the distance, this person hasn't moved in its distance. Okay, so we say that it is at rest, and if we actually calculated the speed, because speed is distance divided by time, it would be 0. Okay, because the slope of that line is 0. So if we're not moving, okay, the graph is a horizontal line. Now, if an object is moving at what we call a constant speed, it means it has the same increase in distance in a given time. So this speed is constant. Okay, so time is increasing to the right, so we're increasing time, and the distance is also increasing with time. So we say the object moves at a constant speed. Okay, and constant speed is shown by straight lines on a graph. Okay, so it could be a straight line like this, or the graph could come with a negative slope. As long as it's a straight line, we say it's a constant speed. Now, when we go to the next one, let's take a look here. I'm asking you, let's look at two moving objects. So here's object 1 and 2. Both of the lines in the graph show that each object moved the same distance because, let's take a look, if I actually take and draw a line, and I will draw a line, which is here, you can see that they both reach the same height, the same distance. Okay, but you can see that one of them, the dotted one, reached that distance faster than the one that wasn't dashed. Okay, so a steeper line indicates a larger distance moved in the given time. It goes faster. Okay, so in other words, it has a higher speed. Okay, now both lines are straight, so both speeds, not seeds, both speeds are constant. Okay, so this one gets there faster, so it has a higher speed. It also has a larger slope as well. Okay, now sometimes what happens is we get a graph that is not constant, that isn't a straight line. And this shows acceleration. Okay, it looks different. Okay, so it's different than constant speed. The line on this graph is curved upwards. This shows an increase in speed since the line is steeper. In other words, in a given time, the distance the object moves is changing. Okay, so there's infinite little slopes. It looks like maybe it was constant here, but then it changed. So it's getting larger. So in other words, it's accelerating. Now, summary of what I've talked with these graphs. A time distance graph tells us how far an object has moved over time. The steeper the graph, the faster the motion. A horizontal line means the object is not changing its position. It's not moving. It's at rest. Time's still going on though. And a downward sloping line means the object is returning to the start. Okay, and I didn't have a picture of a graph there of that one. Now here are a few different things. Okay, so here we have fast and steady speed. We have this other one which is getting faster because it's not constant. We have a steady speed, we have stationary, and this is return to the start. So if you notice when I talk about returning to the start, what's happening here is the height, in other words, the y, comes back to the starting place. Okay, so let's look at a few examples of this. Okay, so it says examine the graphs below, and hopefully you can read them. The first one says, which of the graphs shows that one of the runners started 10 yards further ahead of the other? Explain your answer. So we want one runner that started 10 more. Well, this one started the same, right? So that can't be that one. I'm thinking it's this one, but let's just go through these ones. So started the same. And how do I know that? Well, they both started at 10, so it can't be that one. It can't be this one, almost for the same reason, started the same again. They both started at 0. And the one to your left, well, they didn't start the same. This one started at 0. This one started at 20. So it can't be that one. And this one here, I think we were right. So this one started at 0. This one started at 10. Okay, so the correct one would be this one. Why? By reading the graph, one started at 0. At 0. One started at 10, which was the answer they wanted. Okay, now we go down and see the next question. It says, in which of the following graphs below are both runners moving at the same speed? Explain your answer. Okay, same speed. Okay, well this one here, let's just talk about each one of these graphs. This one here, this one started at 10, this one started at 20. They both ended up in the exact same spot at 4. So obviously one got a head start and still got there at the same time, so it can't be that one. Both of these started at 10. One got there faster than the other, so it can't be that one. Let's take a look at this one. Let's hold on. The same speed, same speed. Well, let's take a look. This one intersects here, so that means one's faster than the other. These ones here look like they are parallel, which it does look that way. And parallel lines have, let me see, the same slope. Oh, if it has the same slope, speed and slope are actually the same thing, right? Because I think it's got to be this one here. Okay, now you heard what I said here. Speed and slope are the same thing. Okay, so I actually could find the equation of this actual line here because I know a lot of things. So I could figure out my delta y is going up from 10 to 20. It's going up 10 units. and my delta x is 4. Okay, remember you got to watch how they've labeled the axis. So my slope here would be 10 over 4, which is the same as 5 over 2. Okay, now that's for that one. Now let's try this other one. Okay, it's going from 20 to 30, so it's going up 10, and it's going over 4. Oh no, guess what? The slopes are the same, 10 over 4. Okay, so they are going the same speed. They're starting at different spots. So for my red one, its equation would be, I guess, distance equals 10, because they started at 10, and then 5 halves t for time. The green one is distance equals 20 plus 5 halves t. So we can actually make formulas, formulas interchangeable for every single one of these. Okay, so if the slopes are the same, they're traveling at the same speed. Okay, so if I look at this one that's beside here, you can see which one is going faster. Well, it's this one here, right? It's this one here that's going faster. I actually can calculate its speed. It's going up. Let's see, this is going 2, 4, 6. Where are they intersecting? 2, 4, 6 roughly. So 6, so it's 16 over 2, which is 8. And it would be 8 yards per second. Yards per second. And if I look at the other one, and I'll switch colors just so we don't get confused, the second one starts here, and for 2 seconds it goes up 6, because we decided that was 6, so it's 6 over 2. 6 over 2 is the same as 3 yards per second. So you can see that we can actually do a mathematical calculation to figure out the actual speed. And that's why this answer D is the correct one. Okay, because their slopes are the same. So they're going 5 yards in 2 seconds. Both of them are. Okay, or 2.5 yards in 1 second. All right, so some questions for you to do tomorrow.